1665.
Good afternoon, students. Now in today's class, we have to discuss with that kinds of getting the to know your data. In the getting the know your data, mainly we have to present what type of data objects and what are the attributes you have to use and basic probabilistic functions These all concepts you have to discuss it in that in this concept. Uh, First of all, what is an attribute? Attribute is a data type. Simply, you can say that it is a data field representing a characteristic uh, or a feature of the data object is called as an attribute. Generally, attributes are divided into four types. Here, those are the nominal attributes, binary attributes, ordinal attributes, and numerical attributes. Nominal attributes are represented generally with the relating to the names. You have to call it as nominal attributes. And what here the values of the nominal attributes are the symbols or names of the things. So generally, you have to call it as nominal attribute. Example, you have to call um, possible values of hair color. Hair color. Generally, what you have to represent. What is the marital status? Married or unmarried? Uh, Hair color black, brown, red. So like this way, you have to represent the particular nominal attribute with the possible values. So these are the this type of attributes are called nominal attributes. And the second one is the binary attributes. Binary attributes are is a nominal attribute. Only you have the two categories of either true or false. That is the states 0 or 1. Generally, you have to call it as binary attributes.
I need to store age.
Third one is the ordinal attributes. Ordinal attributes are generally we have to call it as uh, uh, is an attribute with the possible values that have the meaningful order or the ranking among them, but the magnitude between the successive values are not known. Generally, ordinal attributes are the possible values. Generally, we have to represent it in a order or ranking wise 1, 2, 3, 4, 5, 6, like this. Drink size, small. For example, you have to represent it a particularly uh, possible small teams, medium teams, and the largest teams. And ranking wise, you have to getting the marks for a particular subject, A plus, A minus, B plus, B, like this way. The ranks you have to, professional ranks you have to represent it. Those type of attributes are called ordinal attributes. And the next one is the numerical attributes. Numerical attributes are represented as uh, numerical attributes are measured the quantity represented in integer or real values. Those type of attributes are called numerical attributes. These numerical attributes are divided into two types. One is the interval scaled attributes, and the second one is the ratio scaled attributes. Interval scaled attributes means generally it is measured on scale in equal size units. The values of the interval scale attributes have order and can be positive or 0 or negative. Generally, you have to call. It providing the ranking of values, such attributes allows to compare the quantify the difference between the values. So interval scale generally you have to represent it equal size units. You have to represent it in the interval scale attributes. And the next one is the ratio scale attributes. Ratio scale attributes are numerical attributes, which is the inherent 0 point. That is the ratio. Those attributes are called ratio scale attributes. So ratio scale values can be multiple of another value. Generally, you have these values are ordered. You have to represent it. For example, in interval scale, you have to represent it as ranking wise. Ratio scale attributes are general difference the values, mean, mode, median values. Generally, you have to represent it here. And whereas here, generally, you have to in interval scale attributes, you have to represent the ranking of values. So this is the ratio scale attributes and interval scale attributes. So these are the attributes generally you have to represent it here. And next one is the basic statistical description of data. So whatever the data you have in that data, generally you have to represent it with three things: summarize or analyze the data with the mean, mode, median values. Generally, measuring the values, how we can measure a particular data with the mean, median, and mode values. For example, you have to take the central tendency of the particular data, mean, mode, median values, or mid-range values. Generally, we have to call the most common effective numerical measure of the center of the set of data is arithmetic mean. How we can find out the arithmetic mean? So sum of the values by number of values. Okay, sum of values by number of values. So that is simply call it as a mean. Mean equal to the sum of values divided by number of values. That is simply can get the mean of the given the set of values. For example, we have to see in the basic statistical description of the data, mean value, how we can find out the mean value. Here you have to see this example. In this example, suppose we have the following values of the salaries, $1,000 shown in given below. Here, that is the increasing order 30, 36, 47, 50, 52, 52, 60, 60, 63, 70, 70, 110. So these all are salaries of the various people. How many people are there? Here we have the 12 employees are there. 12 employees salaries information we have to represent. So least minimum salary of $30,000, whereas maximum salary is the $110 salary. So you have to find the mean of this given set of values, or you can call it as salary of the various people. What is the average mean salary of that? Out of 12 people, mean salary is that is the $58,000. So here that is represented as a mean salary of the 12 employees. You want to find out that frequency we can represent it weighted arithmetic mean, weighted average. We want to find weighted arithmetic mean whenever you want to find out. That is the W1, X1, W2, X2, W and Wn, Xn by W1 by W2, W1 plus W2 plus Wn. So how we can find out the median value? Median value you can find out the first you have to given value you have to arrange it into the ascending order. So where the data is ascending order, first you have to represent the number of employees is even number. So that is the n number of employees by divided by 2 plus 1. That is the if the even number, if the number of employees is even number, that is you have to represent a n by 2 comma n by 2 plus 1. So that is the average you have to mean value you have to find out for those two numbers. That is the median value you have to find out. And whereas you have the number of employees is the odd number, in that case the middle of the number you have to represent the median value of the number of employees. So number of employees salary. For example, here we have to consider, that is the total salary for the each person's salaries: $30,000, 36, 47, 50, 52, 52, 56, 50, 60, 63, 70, 71, 110. So total employees is 12 employees. So you can find out the median value. Median value, that is you have to find out. That is the 6 and 7. Both you have to represent it as 12 by 2, and that is 6 and 7. That is values are 52 plus 56. That is the range of, we have to find out the mean. 52 plus 56, that is the 108 by 4. That is the 50, 54. 54 is the median value for the uh, employee salaries. That is the median value. So that is the way you have to find out the median value. Next one is the mode. Mode means generally a set of data is the value that occurs most frequently in the set. So in a given set, which set is the most frequently we have to get? That is the here we have to getting the most frequently. That is the 52 and 70. So those two numbers are most frequently we have to getting. That is the mode of the given data set. And what is the mid-range? Mid-range you have to find out. Mid-range you have to find out minimum salary and plus maximum salary. Average you have to find out the mid-range. Measuring the dispersion of data range quantiles, you can find out the variance and standard deviation of the interquartile range. So here the median and percentile wise 25% and 75%, and median value generally we have to find out with the middle value, that is the Q. Interquartile range, that is you have to find out interquartile range IQR equal to Q3 minus Q1. That is the value you have to get in the interquartile range. So once you have to find out the values with the box plots and variance and standard deviation values, the rho square equal to you have to find out the formula 1 by n summation of x of I minus x bar whole square. So you can get the variance value. So once you have to getting the variance and standard deviation value, you can find out the basic statistical description of data. Basic statistical description of data, you can find out. The basic properties of the standard deviation rho is measured is spread as follows. Rho measured spread about the mean and should be considered only when the mean is chosen by the measure of the center. Rho equal to 0, that is only the whether there is a no spread. That is all observations have the same value. Otherwise, rho is greater than 0. So this is the way you have to find out the variance and standard deviation, and graphic displays of the statistical description of data. So with the both plots, generally you have to represent it, and the variances you have to find out. Quantile plot, that is the QQ plot. Generally you have to call it as. Quantile plot is also called as QQ plot. Generally, QQ plot graphs are quantile of one unvariant distribution against the following corresponding quantiles of another. The diagram will shows that is the QQ plot. This is the diagram which shows that QQ plot. So with the QQ plot, similar way we have to find out the histograms. Histogram generally based on the frequency, we can represent it. Histograms are the least century old and we widely have to use. Histo means pole or mass, gram means chart. Generally, histogram is the chart of the pole. Plotting histograms are graphical methods of summarizing of the distribution of the poles. Scatter plots are data correlations. Generally, you have to represent. It is one of the most effective graphical methods of determining there appears to be the relationship and pattern. So generally here you have to represent the scatter plots. That is the dots you have to represent it like this. See here, this is the scatter plots. This is the histograms. So here scatter plots and as well as positive values and negative values. The positive values are towards with the x-axis to y-axis, y-axis to x-axis. You have to represent the negative axis. And the next one is the how we can represent the visualize. So generally, data visualization aims to communicate the data clearly and effectively through the graphical representation. Data visualization have been used extensively in many applications. For example, at work operations, tracking progress of the task. So first one is the pixel-oriented visualization technique. So generally, in the pixel-oriented visualization techniques, you have to represent create a M windows on the screen, one of the each dimension. The M dimension values of the record is mapped to the M pixels to the corresponding positions in the window. The colors of the pixels you have to reflect the corresponding values. That is simply you can call it as pixel-oriented visualization technique. The pixel-oriented visualization techniques, see these diagrams shows a particular attribute visualization, pixel-oriented visualization for the four attributes by sorting all customers in income and ascending order. And the second one is the geometric projection visualization techniques. Geometric projection visualization techniques. The visualization two-dimensional visualization technique with the scatter plot. Generally, we have to represent it, and the diagrams will shows like this. Icon-based visualization techniques. Icon-based visualization technique is the small icons to represent the multi-dimensional data values. Two popular icon techniques: Chernoff faces and stick faces. Generally, you have to call it as icon-based visualization techniques. So here the diagrams will shows the icon-based visualization techniques regarding to the iris data. And a similar way, hierarchical visualization techniques. uh, hierarchical visualization techniques. Generally, you have to represent it with the worlds within the worlds. Generally, you have to represent it. Visualizing the complex data and relations, you have to represent it with this measuring the data similarity and dissimilarity with the data visualizations. Data visualizations, once you have to complete it, then you start the measuring of the data similarity and dissimilarity. In the data similarity and dissimilarity, generally you have to represent the diseases influence the graph of the people last 20 years old in Matham's data. Generally, how the data, how you have to influence the graph of the people of the, a particular disease. That you have to represent it with this data matrix versus dissimilarity matrix. Proximity measures of the nominal attributes. The nominal attribute can take on two or more states. For example, map color and nominal attributes that have the five states: red, yellow, green, pink, and blue. The similarity of the data. Minkowski distance, that is the dissimilarity of the numeric data you have to find out. Euclidean distance of the Martin distance, we can find out that between the 2 points, that is the generally distance between the 2 points, you know that root of x square minus x2 minus x1 over y2 minus y1 over 2. So similar way here we have to represent the points, that is the x1 x2 whole power h and x1 2 and I2 minus j2 whole power h, x of ip minus x of jp whole power h. This is the way you have to find out the Minkowski distance you have to find out. That is the dissimilarity of the numerical data in Minkowski distance. Generally here you have to represent the Euclidean distance. Proximity measures, generally you have to represent the ordinal attribute. The values of the attribute where ordinal attribute have the meaningful order or ranking about them. Generally here we have to represent the dissimilarity between the ordinal attributes. That is the diagonal elements are represented with the 0 and you have to represent the values. Lower diagonal elements are generally 0, 1.50. Like this way you have to. Similar way 0.5, 1, 0.50. So this is the proximity of the measures of the ordinal attributes. The dissimilarity between these two ordinal attributes. Dissimilarity of the attributes are mixed type. You can represent it with this diagram. Uh, Cosine similarity and dissimilarity between the attributes are mixed type. Cosine similarity between the two term frequency vectors, that is the mod of x2 minus x1 whole square, x2 y2 minus y1 all. Like this way you have to represent the diagrams. This is the end of the second unit. First unit. Next one is the data pre-processing. In the data pre-processing, generally you have to represent it with the before the data warehousing. So you have to construct the data warehouse. First, you must perform the data pre-processing. The data pre-processing mainly you have to perform the 4 steps. First one is the uh, data cleaning, data integration, data reduction, and transformation and discretization. So these are the four steps you must be following in data pre-processing.